spot. Okay. So, inverse functions. It's probably been a while since you guys did any inverse functions, but you used to do inverse functions with just lines where you switch the x and the y and you solve for the new y. I don't know if you guys remember that. No? Okay. So basically, the x and y values are interchanged, and the graphs always reflect over y equals x. So inverses like undo each other. So if the square is one function, the square root is the inverse of that function. And if you graph those two graphs, they reflect over the y equals x line. So do trig functions have inverses? In order for something to have an inverse, it must pass what's called the horizontal line test. Passes horizontal line test. In other words, it can only cross one time. So first, let's just look at a basic sine graph. We can all do a basic sine graph, right? We start here in the middle at 0, 0. We go up at pi over 2 to 1. Back down at pi, and if we go the negative direction, we go this way. And you should just kind of sketch it in because, oh, actually, we could draw this whole thing. All right, let's draw the whole thing. So, y equals sine x. The problem is that it will fail the horizontal line test. Like if I just draw a line straight through here, how many times is it going to cross? Twice. So we need, well, for that window that we see, if we keep going, it'll cross like millions of times, right? So we got to restrict our domain. So when we restrict our domain, we're going to restrict it from here, negative pi over 2, to pi over 2. Because what happens when I only look at this part of the graph? A horizontal line will only cross one time. So I'm going to erase these little pieces of my graph right here so that my sine graph only goes from negative pi over 2 to positive pi over 2. That way I can find an inverse. So you're only allowed to get an inverse when the graph is 1 to 1, which means it's going to pass the horizontal line test. So now my domain is from here to here. So it's going to go from negative pi over 2 to positive pi over 2. And technically, guys, these are not asymptotes. Sorry. They're just showing that I'm restricting it, okay? Those are not actually asymptotes. And my range is going from negative 1 up to positive 1. So this is the inverse function of sine, right? We write it as sine inverse, or we write it as arc sine. And what I'm going to do is flip everything. So inverse functions switch x and y. Think of it as switching your coordinate points. So this coordinate point right here is pi over 2, comma 1. This coordinate point right here is 0, 0. And this coordinate point is negative pi over 2, comma negative 1. Right? What I'm going to do is switch those 3 points and draw my new graph. So I now have the point 1, comma, pi over 2 over here. So I go right 1, up pi over 2. When I flip 0, 0, it's still 0, 0. And over here I'm going to flip this one. So it's negative 1, negative pi over 2. All right, what happened is my sine graph, which originally looked like this before I cut it down, right, is going to turn sideways, all right? So it's actually, yep, it's going to look like this. And I could kind of keep drawing this. You can just visualize it, but I have to keep it restricted, right? So the whole graph just flipped. Okay, so what happens to my domain and range? Well, if I flip my x and y, I flip my domain and range. So you can look at the graph, or you can just look at what you just wrote, because the domain is now the range of this graph. And I can also, look at this. It's going from negative pi over 2 to positive pi over 2, right? And my domain is going from negative 1 to positive 1. All of these are inclusive. We don't have any asymptotes. All right, so hopefully you guys remember lava zones. This lines up with those. Because remember, for sine inverse, we only go to positive pi over 2 and down to negative pi over 2. We're only in quadrants 1 and 4. So that's the same thing, okay? All right, now let's look at a cosine graph. So we've got a basic cosine graph, which starts at 0, 1. comes back down at pi over 2, down to the bottom at pi, and I can also go this way, right? And I'm just going to kind of sketch it in because we're going to have to restrict it. So again, we can only have an inverse function if it passes the horizontal line test. So where does it pass the horizontal line test? Well, I can't do the same as the sine, negative pi over 2 to pi over 2, because it would fail. It would cross twice, right? So what are our lava zones for inverse cosine? 0 to pi. Yeah. So we're going to actually restrict this one from 0 to pi. I guess I'll make these solid lines. You don't really need those lines, but I'm just showing you where I'm restricting it, okay? They're not asymptotes. And I'm going to erase this part of the graph over here because that makes this function be 1 to 1. So this is the part of the graph that we want. It's just this little piece of the cosine graph. It's cute, all right? So my domain is now 0 to pi, and I'm including both. And my range is going from -1 to 1. So I've got 3 points I'm going to flip. So this is the point 0, 1. This is the point pi over 2, comma 0. This is the point pi, comma -1, right? And we just flip them. So now I have a point at 1, comma 0. Flipped that guy. Now I'm going to flip this one. I have a point at 0, pi over 2. And I have a point at -1, comma pi. So if you can picture this, right, this is the cosine graph flipped. So it's curving a little bit this way, a little bit this way. And if I kept going, right, it would look like this. But we don't keep going because we have to be restricted. So it's just this tiny little part of the cosine graph flipped because we switch x and y. All right, what happens to my domain and range? They just flip. So the range of this one is the domain, -1 to 1, which you can see right here. And my range is going to go from 0 to pi. All right, tangent. Tangent graphs go through what point? 0, 0. Good. And we have asymptotes at pi over 2 and -pi over 2. And remember, they kind of like go through, actually, do you guys remember pi over 4, the tangent's 1? Do you guys kind of remember that? Cool. And at -pi over 4, the tangent's -1. And it goes down. And we could keep drawing a whole bunch of these, except then it would fail the horizontal line test, right? So I actually only need that one right in the middle, because then it passes the horizontal line test. So we just need one tangent right in the middle. So the domain of this graph is what? Yeah, it's -pi over 2 to +pi over 2. But do I include these pi over 2's? No, it's an asymptote, so make sure you do parentheses. All right, and my range is what? Yeah, how far down, how far up, -infinity, +infinity. All right, now we're going to flip some stuff, right? Notice my asymptotes. Those are easy to flip, right? If this is an x equals graph and it goes through -pi over 2, it is going to become a y equals graph that goes through -pi over 2. So you just flip the direction. It cuts through the x-axis at -pi over 2. Well, now I'm going to cut through the y-axis at -pi over 2. And this one cuts through at +pi over 2, so now this one's going to cut through on the y-axis at +pi over 2. All right? And we can flip those points. This one in the middle is 0, 0, so I still have 0, 0. This point right here is pi over 4, comma 1. So when I flip it, it's 1, comma pi over 4. And this one's -pi over 4, -1. So now I go -1, pi over 4. And some of you may be able to just visualize this without plotting those points. Okay, but it looks like that. It's going to hug your asymptotes. And my domain and range are going to flip, right? So my domain now goes all the way left, all the way right. And my range goes from -pi over 2 to +pi over 2. And we're not including because of the asymptotes. All right, those weren't too bad, right? Oh, we got cotangent too. Cotangent's not bad either. Cotan and inverse cotan. All right, so first of all, cotangent, you want to memorize the asymptote goes through where? Yeah, so I have an asymptote that goes through 0. And then we have an asymptote that goes through pi. And our graph goes through pi over 2. And then it goes the opposite way. And it actually does cross at this like pi over 4 1 point and the 3 pi over 4 negative 1 point, if it helps you to flip those coordinates. Again, we only need one of them, so it passes the horizontal line test. And now my domain would be what, you guys? 0 to pi. And are we including 0 and pi? No, we've got asymptotes. And my range would be what? Thank you so much. All right, good. Now let's flip our asymptotes first. That makes this easier if we flip them first. So this one goes through 0, and it is vertical. Now I'm going to go through 0, and it is horizontal. So I did cross the x-axis. Now I'm crossing the y-axis. This one crosses at pi, so I'm going to cross at pi on the y-axis. And let's flip our points. Okay. Easiest point to flip is this one first. This is pi over 2 comma 0. So now it's going to be 0 comma pi over 2. And this point is pi over 4 comma 1. Now it's going to be 1 comma pi over 4. And can everyone see where this one's going to be now? Just put it there. We got our little curve that starts hugging. Whoa, I kind of didn't do that very. Whoa, that was hard. There you go. Tried. Okay. And our domain and range flip. So my domain is negative infinity, positive infinity, and my range is 0 to pi. Side note, what are cotangents? Lava zones. 0 to pi. Cool. Cosecant. All right. Can everyone graph a normal cosecant graph? We're about to find out. All right, let's see. First graph, a sine graph. Just sketch it in lightly. All right, little sine graph, which goes through 0, 0, up to 1 at pi over 2, back to 0 at pi. Right, so everybody sketch in just a sine graph. What? Colin? This is going to be annoying. It's going to be annoying. I agree with you. All right, so now we make it a cosecant graph by putting what at all the zeros? Yeah, we have asymptotes when we flip these, because you flip the coordinates and you get some zeros. So we got asymptotes here, 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 and here. And then we have our graphs, which look like this, right? We get our little like parabola looking things, right? The reason I'm sketching this in is because we have to restrict it, because it doesn't pass the horizontal line test, right? We restrict it the same as sine. So remember that, ooh, that was a yellow. These are the same restrictions as the sine graph, all right? And we restricted our sine graph right here, because then it was 1 to 1, right? From pi over 2 to negative pi over 2. So what I'm going to do, and you guys don't have to like erase and everything because that's kind of a pain. I'm going to on my lovely smart board, but you guys don't have to. All I want you to do is darken in. The actual answer is only going to be this part of the graph, which gets close to the asymptote, and this part of the graph, which gets close to the asymptote. That's really all we need. And we do have a vertical asymptote at 0. All right, so my domain is going to be negative pi over 2 to 0, because we have a little break right here. So normally it's like negative pi over 2 to pi over 2 for the sine graph, but we now have this asymptote. So it's negative pi over 2 to 0, and we are including the pi over 2. It's a solid circle, but we're not including the 0. And then we do a union, and we do 0 to pi over 2 with a bracket. Okay, and then your range is how far down, how far up. Well, we're not doing the whole graph. We're going from negative infinity to what? to negative 1 on the y-axis. Good. So I'm going negative infinity to negative 1, and I am including that point, negative 1. And then there's a break, so I have a union, and it doesn't pick up again until right here. And now I'm going 1 to infinity. And I should be including 1 and negative 1. All right, don't zone out because this is the hard part, okay? We just got to the hard part. That was not the hard part. This is it's sort of hard, but not really. All right, so it's not that bad if you've been following. So you guys, we've got this asymptote. How do I flip this asymptote? I just flip it. There you go. You just flip it. So now it was going through 0 across the x. Now I'm going to go through 0, whoops, across the y. All right, and then we flip our points. There's two main points that you need to flip. This point right here. What is this point? Pi over 2 comma 1. Now I'm going to flip it. 1 comma pi over 2. Okay? And there's this point. This is the point, negative pi over 2 comma negative 1. So now it's going to be negative 1, negative pi over 2. And now all you need to remember is it gets closer to the asymptote and they point away from each other. Okay? So that helps if you remember that. It goes really close to the asymptote and it points opposite directions. Boom. You don't get it?
That's okay.
Okay. So now we flip our domain and range, or just look at the graph. I'm going from negative infinity to negative 1. Are you crying? Okay. And from 1 to infinity. Don't cry. All right. And then we're going our range, negative pi over 2 up to 0, but we have that break. And I'm including negative pi over 2. Union, 0 to pi over 2. What is the other union? What do you mean? This one? Oh, this part? 1 to infinity? Yeah, sorry. Ran out of room. I know, it's messy. All right, let's do a secant graph. So start with a cosine graph, right? So everybody can start with the little cosine graph. Starts up at 1. Back like this. Boom, boom, boom. All right, sketch it in. And then I want you to always think same restrictions as cosine, how we had to restrict cosine, which was from 0 to pi, all right? So we always restrict the sines, negative pi over 2 to pi over 2, and restrict the cosines from 0 to pi. So this one I'm going to restrict from 0 to pi. But before you restrict it, you got to visualize what you're doing on this graph. So where do my asymptotes go? Across all the zeros, right? And then we have all our little parabolas that we can draw in, and I wouldn't fully draw them in yet, or you can just do them really dark after you do it. Okay, we can do all of our parabolas, boop, 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 boop. But we only need the part of the graph from 0 to pi. You don't have to draw those lines in. I'm just showing you 0 to pi. All right? And so I can kind of like just erase all the stuff I don't need. And the main part of the answer that we need is just this little halvesy parabola that gets close to the asymptote, and this little halvesy parabola that gets close to the one asymptote that we need, okay? Okay, so my domain would be 0 to pi over 2, and then we have this break. So I'm going to go 0 to pi over 2, and we're not including pi over 2 because it's an asymptote. And then we pick back up at pi over 2 and all the way over here to 1. Okay, my range goes all the way down, all the way up except for that break in the middle. So I'm going to go from negative infinity up to negative 1 right here. And I'm including that point there, the negative 1. And then I pick back up at positive 1 and go up. I don't feel like rewriting these, you guys, so just kind of like arrow it on over because you know that they switch. Whoop. Is that okay with you guys? Okay, I don't feel like rewriting them all. But let's draw this graph because that's like important, all right? Of course. So we gotta draw this graph. Oh man, it's like there's no room here. So this is my inverse secant graph. First thing I would flip is the asymptote. It's going through 0, and so this one's gonna also go through 0. I think I messed up when I moved this picture, you guys. Yeah, that helps a lot. So it's not going through 0. I just moved my graph. It's going through pi over 2, okay? Hopefully yours is also going through pi over 2. So I'm going to need to just erase the lines I drew all over the place. Okay, so I've got pi over 2. Draw yourself an asymptote. Boop-a-doop-a-doop. And flip just those 2 points, and then curve them away from each other and towards the asymptote. So what coordinate point is this right here? 0, 1. So now we're going to do 1, 0. Okay, what coordinate point is this right here? Pi, negative 1. So now do negative 1 pi. All right, now your graph is going to hug the asymptote and point away from each other. So I get like all close to my asymptote and point away. And flip your domain and range. Okay? No, we don't. We don't. You don't do shifts and period changes. This is all you'll have to do. So look at your notes when you do these. All right. So quadrants for lava zones, just a reminder. Okay, which ones are quadrants 1 and 4? Well, it's inverse sine because it goes from pi over 2 to negative pi over 2, which is what we just restricted our graph to. And that's the same as inverse cosecant and, yes, tangent. Okay, and then we have these lava zones, which are quadrants 1 and 2. And so it's from 0 to pi. So which ones go from 0 to pi? That would be our cosine inverse and our secant inverse. Yep, inverse secant. And our inverse cotangent. Okay. I don't think we need to do these because I feel like you guys all just check some and make